I recently received a kit I ordered from Almost All Digital Electronics to build an LC meter. I'm gonna open it up, put it together, try it out. First though, let's take a look at how it works. This is the schematic from the manual. You can see you've got like a LC oscillator over here. This is the tank. You've got L1 and C1 are the main reactive elements. And then U1 is the amplifier. Over here you got a PIC microcontroller that's sampling off the output of that comparator to get the frequency it's oscillating at. When it starts up, it's just got L1 and C1 in parallel. You can measure the frequency those oscillate at. Then it's got a precision capacitor here. You can switch in to do the calibration. It'll store those values. Then when you put the device under test here between these terminals, you activate either the LXA switch or the CX. That's LX and CX. They're in two parts. There's an A part and a B part. But when you activate the LX switch, that's going to put this L1 inductance in series with the device under test, and C1 will be in parallel with it. So that's for measuring an inductance. When the CX switch is active, that'll put L1, C1, and the device under test all in parallel. That's for measuring capacitance. Like I said, these switches are two parts, so over here also you've got the other half of the switch, and that just gives the micro. I assume these pins are set with internal pull-ups. So it just gives a micro an idea which switches you have active. And that's important too when it's doing the calibration. But of course, when you go to make a measurement, it needs to know what type of device you're measuring so it can do the math correctly to calculate the inductance or capacitance. And then of course it's got these lines here to drive the display. You got display contrast adjust over here, and just a simple regulator here, power switch, battery, a little bit of decoupling. Here's your crystal for the micro. That's going to be the frequency reference, so I assume that's a reasonably precise crystal, because that's what it's going to compare this frequency input from the comparator to. So, well, let's go take a look at it. Alright, let's see what we got in here. Instructions, good. Got the case. Packing material. Oh, big bag of parts. Okay, cool. Alright, let's see what our parts are, huh? We got like a parts list here, but it says it's not a complete inventory. Just help ID stuff. That makes sense. Let's see what we got. A little packet here, I'm gonna guess. Yep. This is that precision capacitor. It's two capacitors that have been hand selected to make up the correct value to within 0.5%, I think it said. And we got a header for the display, a socket probably for that microcontroller. There's a circuit board. Looks nice. There's the intelligent display. Got some buttons and switches. What else have we got here? Got some little clip leads. Oh, that's nice flexible wire too. Good stuff. Battery connector. There's that comparator and the PIC micro. A little socket, that'll be for the comparator there. Got the binding posts. Some resistors. There's your big inductor L1. Got some capacitors, looks like. More capacitors. The button caps here. And here's the other half of that pin header there. And some hardware probably for those binding posts, eh? What's this guy? It's that voltage regulator we saw. Got some more little capacitors there. A couple more resistors. Another cap. There's that crystal, little 8 megahertz. Probably one of those little strip crystals in there. Losing some hardware. Guessing those for the circuit board, and these are to hold the case together. This is that little relay to switch in the precision cap for calibration. That's going to be the potentiometer to adjust the display contrast. And another little polyfilm cap probably there. Alright, well, let's see how it goes together. If you receive some extra resistors or capacitors, ignore them. I dropped them in by mistake and it was not worth the effort to fish them out of the bag. Okay. A couple of little details and gotchas. Particularly having to do with L1. It says it works better if you install it one way rather than the other. Okay. And setting the angle of the pin header on the display so it'll look nice through the window. It says put that at a little bit of an angle, so we'll get that when we get into it. Alright, well, let's build the board. Now we gotta do the display. Now it says this angle here should be a little over 90 degrees. It says about 100 degrees. It says it'll be more parallel to the window because of the looseness of the sockets. Looks to me you're going to hit that angle if you just let the pins rest the way they want to in there. Well, let's tack one down and see what we get. Okay, now we're putting in the chips. What next? Install the switch caps. Right. All right, sits in there like so. Now Instructions say this would be a good time to power it up and be sure it functions. Makes sense to me, but I gotta go fetch a 9-volt battery before I can do all that. Might fetch a little lunch while I'm at it. Alright, found some lunch and a battery. Let's see what we got here. Yuck. Alright. Put the display on there. And hook the battery up. Hit the power and see what we get. Hey! It says it's ready to measure. All right. See, I got something here we could measure, huh? All right, that looks good. Now let's drop something on there. Where's that? 2.2. There we go. Oh, look at that. 2.253. That's what we're talking about there. Let's try that 1.5. 1.515. Oh, 506. Nice. Cool. All right, wow, we got it built. So thanks for coming along on the adventure. If you'd like to see more of it, hit the subscribe button. I'll try and get you some more like it. See you next time.